Hello and welcome all. We recently witnessed a massive operational disruption with IndiGo Airlines cancelling flights, citing issues complying with the new DGCA FDTL norms. FDTL stands for Flight Duty Time Limitation. To the general public, this looks like a shortage of pilots. But for a site reliability engineer, this looks like a catastrophic failure of capacity planning and governance-driven availability. I'm Kaushal, and today I'm breaking down the IndiGo FDTL crisis through the lens of a site reliability engineer. Because trust me, this incident looks exactly like a reliability failure in a large-scale distributed system. Let's understand the context first. FDTL is basically the aviation world's version of a rate limit, but for humans. Let's translate aviation into tech language for a second. DGCA introduced new FDTL rules, Flight Duty Time Limitations. In simple terms, they increased the mandatory rest for pilots. In SRE terms, the government basically updated the config map for the pilot class object. They introduced a stricter rate limit. Before, a pilot could run X hours. Now, a pilot can run only X minus Y hours. Throughput drops. Latency increases. And the whole system needs more capacity. Let's tie this back to SRE and operational resiliency for a moment. At the heart of this entire mess is one simple idea: capacity planning. Because as much as we wish, humans don't scale like cloud servers. In tech, if one server's capacity drops, the fix is easy. Spin up more servers. But airlines aren't AWS. You can't spin up a senior commander in 60 seconds. A pilot takes years of training. That's what we call provisioning latency, the delay between needing a resource and actually having it. And IndiGo's real mistake? They never modeled the new capacity requirements created by the tightened FDTL rate limits. They just assumed the existing crew would somehow stretch to fit the rules. But SREs don't assume. We don't pray. We don't hope for the best. We simulate. We model. We forecast. We plan. Because hope is not a capacity strategy. This brings us to governance. In modern operations, we treat compliance as policy as code. If something violates a rule, your system should reject it before it reaches production. So the big question is, did IndiGo's scheduling software catch invalid rosters? Or did the violations only show up when flights started collapsing? If the system allowed a schedule that needed more pilot hours than legally permitted, that's a governance failure before it became an operational failure. That's called configuration drift, when what your system needs diverges from what the rules allow. And drift always leads to outages. Let's talk about error budgets. An error budget defines how much failure you can afford before users lose trust. IndiGo was operating right at the edge of their pilot capacity. No buffer, no redundancy, no slack. In SRE, when you exhaust your error budget, you freeze changes. You stop shipping new features. You stabilize. For an airline, that means stop opening new routes. Reduce flight frequency. Add buffer hours. IndiGo didn't do that. They ran at 100% load, on 80% capacity, with new regulations incoming. The result? A predictable system crash. So, what does a resilient aviation system look like through the SRE lens? First, observability. We need dashboards for human reliability the same way we track server reliability. Duty hour saturation, fatigue forecasts, staffing gaps, all visible in real time. Second, chaos engineering. Simulate disruptions before reality hits. Ask, what happens if we lose 10% more pilot hours? What if night duty rules tighten even further? Test it in a sandbox, not on paying passengers. Third, automated governance. Compliance should be a hard constraint in the scheduling algorithm. If a roster violates FDTL rules, it should fail to compile, not fail in production. And finally, operations resilience isn't just for servers. It's for airlines, logistics, hospitals, anywhere humans and systems work together at scale. When we treat physical operations with the same engineering rigor as digital operations, we don't just save uptime. We save weekends. We save holidays. We save reputations. Stay reliable. Stay resilient. And if you found this breakdown helpful, hit like, subscribe, and share it with someone who loves SRE and resiliency.